Okay, does anybody need another 30 seconds or so? That'd be good. Okay, so this is what we had for chapter 1. Madison, can you see my screen okay?
Yes.
Okay, so we talked about the stimulus, which is what the receptor reads. And receptors are usually cells or groups of cells that can sense whatever that stimulus might be. So it might be mechanoreceptors, chemoreceptors, thermoreceptors, whatever. The control center always being the brain, because that's what's going to intake that information and respond to it. The effectors are the cells or tissues that actually are going to do something. It could be like a gland, and in this case, it's going to be a gland that releases something. And then the response is, you know, what happens in the body. So we use the thermostat, you know, the thermostat example. Today, what we're going to really focus on is over here with the effectors and the response. And 231 gives us 2 examples of the hormones that are regulating calcium levels in the blood. We are going to look at parathyroid hormone and calcitonin. And they have opposing effects. And we don't get to the endocrine system in 151, but hormones are often like that. There's often one that has, you know, a raising effect, an elevating effect, and then one that has a lowering effect. Same thing with like sugar and salt, things like that. So what we're going to do here is we're going to make a new one. And I know this kind of looks a little crazy, but we want to like not really pay attention to these two as much. We want to look at this side, okay? And please note that it doesn't connect, okay? So we're going to go through it, and you can probably spread it out a lot more than I have on this screen here. It is not.
Okay.
So yeah, so if you want to draw it, you can draw it, and if you're drawing it, just kind of, I'm going to do it step by step. So just kind of follow my steps, and yours can spread out a little bit better than this. All right. So we still are going to have a stimulus, the sensory, and then the control center, just like we did over here. We're just not going to really name a lot of that. We're really focusing on what's colored. Okay, so on page 230, we see the hormones that's going to, the hormone that is going to regulate when lower calcium ions are in the blood. So our stimulus here is going to be low calcium. Okay, so we have a receptor that can indicate that the calcium is low. We have our brain that's going to do something about it. So now we're going to talk about, okay, what does the brain react to? So we're going to talk about this side here with the effectors and the response. So in the case of low calcium, the effector is going to be the parathyroid gland. And that parathyroid gland is going to, bless you, is going to, as the book says, it's going to release the parathyroid hormone. So I'm just going to put the hormone right here, parathyroid hormone. I do have a PDF of this. If you want one after this, I'll a little clearer. If Madison, if you want a PDF of this graphic organizer, I can get that to you. Just remind me at the end of class.
Okay.
Okay, so that's going to affect 3 places, and you can see the pictures there. It's going to affect the kidneys, the bones, and the intestines. And if you step back and think about, well, what do the kidneys, bones, and intestines have to do with calcium? Well, the kidneys are cleaning out the blood. The intestines are taking stuff in from food. And the bones, remember, appositional growth with the osteoblasts and the osteoclasts are constantly maintaining the bone matrix. So the bone itself can actually release or take up calcium. All right, so if we have low calcium, let's start with the bones. What kind of cells are going to break down bone matrix and release calcium? So we had 4 types of bone cells, the osteogenic, osteocytes, osteoblasts, osteoclasts. Which one are going to break stuff down?
Is it osteoblast?
So when you think osteoblast, think of the B, think of building.
Oh, okay.
So it's the clasts. Yeah, I don't have a good C word that means breakdown. Anybody think
crash?
Crash. There it is. So osteoclasts are going to start to break down bone and release calcium. Okay, now let's think about the intestines. Hopefully you're drinking your milk. What are the intestines going to do in times of low calcium?
Are they not going to digest? No.
So the main function of the intestines are going to be absorbing things. So that's why they're so big. There's lots of surface area.
Okay. So do they like absorb extra other substances and everything?
Exactly. So the intestines are going to, well, as a direction from parathyroid hormone, now all of these are going to be because of parathyroid hormone stimulating it, the intestines are going to start to pick up more calcium from food. So absorb more calcium. And that's similar to the kidneys, but maybe we should clarify that. This is going to absorb it from the food that we eat. And so the kidneys have another, it does talk about calcitriol. It has another hormone, calcitriol, that is being produced. So sometimes endocrine glands, there's actually kind of a cascade of hormones that are produced. So this is one of the cascades, calcitriol. Calcitriol is released. Yikes, sorry about my handwriting.
All good.
And that's going to pick up more calcium. So it's going to have a similar effect as the intestines.
Where is that calcium like taken from?
So in the kidneys, it's taken from the blood.
Blood. Okay.
Okay, because there are 2 big vessels, one coming in, one coming out from the kidneys. And what kind of effect, I shouldn't say effect, I should say response will all this have in the blood? What's our pink box? What's the response to all this? It is a negative feedback.
Positive. Well, can your body produce more calcium?
This is how it's producing more
Okay,
calcium.
so then the end thing is just like more calcium.
You got it. Calcium increases in the blood, in the body. So it is a negative feedback. We are returning to our maintained steady state.
So is the graph going like from like the calcium to the receptor to the brain to like is it going that way or is it going like
Yeah, it's kind
because
of this way, like clockwise, but then it stops. So it's not reconnecting anywhere, it just kind of stops. So you could make this as a flow if you want,
okay.
just like a long flow. Okay, so we're gonna do that now for the other system when there's high calcium. So you're gonna see the same thing here. The only difference is there's higher calcium now in the blood. So again, we've got our sensory receptors and we've got our brain as our control center. So we're kind of ignoring those two right now. And this is the one on page 231 in blue. And so our effector here is going to be the thyroid gland. And this is going to produce calcitonin.
What is the difference between the thyroid gland and the parathyroid gland?
Sure.
Like, is it just this or?
So thyroid gland is going to be like a butterfly.
Okay.
And it's not up here. It's more like it's down
Right
here, right?
Okay.
Behind the thyroid are four little pea-like glands called parathyroid. So para meaning next to or on top of. Okay, so they're actually on the posterior side, but they're right with the thyroid gland. And the difference is in the hormones that they produce.
Okay.
Okay, so we're gonna do the same three responses. We talked about bones, kidneys, and intestines. And so you might be able to kind of predict what's going to happen with these. So let's start with the bone. The calcitonin is going to reduce what type of cell activity? Osteoclasts. So there's less, I'll just say less osteoclast activity. Osteoclast activity. Yes. Now, if there's more calcitonin, there's usually less parathyroid hormone. So some of these effects are like, well, because there's calcitonin, parathyroid's not active. And so that group of activities that happens because of parathyroid hormone are not going to happen. The calcitonin in the kidneys, for example, that is going to inhibit calcium reabsorption.
I think I missed it, but what is this example that you're doing?
This one is if the calcium levels are high in the blood.
Okay, thank you.
You're welcome.
And then what causes like your body to have too much calcium? Like, is it just, what would be the cause of this?
What on a daily basis, the chemicals in your body are fluctuating. So in order to maintain it, this would be a normal process to
Okay, so
maintain
this
it.
isn't like something happens and like
This is
pregnancy
not a
normal.
response to some kind of crazy thing happening to the body, like an injury
Yeah,
or, you know, some kind of chemical difference. This is normal maintenance.
like every okay.
Yep. So all these hormones that are part of the endocrine system are what are normally maintaining our ranges.
So say you were to like not like drink milk or anything, where would you get like your calcium from?
Your bones, which is bad. So if you don't drink, if you don't have like an intake of calcium, then your body takes it from your bones because there's nothing in your blood and there's nothing in your food for your body to take it from. So it'll take it from your bones, which means osteoclast activity exceeds osteoblast activity, and that can lead to osteoporosis.
Oh, okay. I guess I should start drinking milk then.
Yes, no, Madison, you and me are like spirit animals because I hate milk. I hate the taste of it. I blame my mother because she made me drink a glass of milk with my dinner every night. But I don't really blame her. I don't like it. And so I have to take a calcium pill every day because I don't like it. And I really don't get it. Like I yogurt, but I don't really get it anywhere else. So yeah, vitamin supplements.
I don't even really eat any type of dairy except for cheese.
Yeah. So maybe a calcium supplement in your vitamins every day.
Yeah, I'll look for that.
Your doctor though. Okay, the last thing, let's round this up is the intestines. Obviously calcitonin is going to have that opposite effect than the other one. So it's not going to be absorbing calcium anymore. From food. And all of these are going to have the same effect, which is to reduce the calcium in the body. And remember, this is separate. I need to move those around for next time. Okay, so that's that, along with understanding the cell types of bones, is really the idea of bone homeostasis. That's kind of the big idea. Now, some of the things that can happen if these are out of whack, if one side of activity exceeds the other, you can jump to, I'll jump back, I guess, this stuff on osteoporosis. Oh, I missed it somewhere. Okay. Maybe it's one of the other chapters. It might be in like the chapter 7 or something. I will find it, but that's the stuff that shows when you're starting to wear away and degrade the bone. Must be in chapter 6 or 7. I don't know. Anyway, I'll find it. Then in chapter 6, there's some more bone abnormalities, and a lot of them are controlled by the endocrine system, because the endocrine system not only is the endocrine system controlling the daily amounts of calcium in your blood, but it's also controlling the stuff that, the hormones that control like appositional growth and endochondral growth. And so if you mess with either of those, then you can have like achondroplasia or Marfan syndrome, which is being very short or very tall, very long bones or very short bones. So the abnormality stuff I want you to take a look at. Again, I cannot believe I can't find the osteoporosis stuff. But that's okay. You guys have any questions?
Yeah. I was trying to write down what you had just said about the endocrine system. I missed the last part where you said what hormones that control the calcium that control it?
Okay, so you also have hormones that, like growth hormone, that affects the growth plate during endochondral ossification, which is the lengthening of bones. Technology is not healthy. It's me. Okay. And so let me just show you some of the examples from the book here. Not having luck today. Or not. So growth factor, growth hormone, this is the pituitary gland. And here you can see achondroplasia and Marfan syndrome. You can also see other like degenerative diseases. The video I made yesterday has the fractures, so make sure you take a look at that again. Here we go, osteopenia. It is in chapter 8. So if you take a look at a normal bone versus an osteoporotic bone, you can see the holes. You can see the osteoclast activity is just degrading that bone. Okay, so again, we need that balance, that homeostasis. Any other questions about chapter 6? All right, I was hoping for more time. I'm sorry, guys, but last 10 minutes, you can work on chapter 4-5 practice quiz, chapter 6 practice quiz, lab tests, whatever you need to work on. And we'll see you on Monday, Madison.
Yes. I have a question.
Sure.
So for the lab,
Yep.
I'm still recording the last one because I'm still looking for another one.
Okay.
So I'll probably turn that in like later on today, like after I leave work.
That's fine.